Hi, I'm Dr. Andre Mazzolani, a faculty member in the Department of Mechanical and Aerospace Engineering at North Carolina State University. It obviously is more difficult to design something that transforms, and there's really a lot of different situations when you want to do that. The most obvious one is if you have to accomplish many functions with a single device. But then there's also, for example, if you only have one space available and you want to have lots of events in it, for example, the sports arena. And then, of course, if your device is going to be experiencing many different types of conditions, for example, the rover on Mars, and you have flat terrain and rugged terrain. Then there's cases where you want to save space. An airplane on an aircraft carrier can fold up its wings so you can put more airplanes on the aircraft carrier. Or you might have a device that you are rarely, if ever, going to use. For example, an airbag in a car. You obviously want to be able to take a very small amount of space when it's not needed, and then expand, obviously, when it needs to perform its function. You're not doing transformation just for its own sake. It's because you either want multifunction, different environments, you want to save space. These are some of the key reasons why you want to consider transformation capabilities in your design. When you make something transformable and you have moving parts, you do have issues of reliability and durability that you need to consider. And in general, the more transformable a device is, the more things there are that can break or fail on the device. So it doesn't mean that it shouldn't be transformable, but you need to consider and always ask yourself the question: is the added complexity of making the device transformable, is it worth the increased functionality of the device? So I think keeping that in mind is very important. I really like, taking walks outside. I like nature documentaries. So anytime I see anything an animal or even a plant does that's kind of interesting, I'll even make a note of it in a notebook, and then later on I can come back and when I'm trying to think of ideas. It helps just to be observant. Take any room in your house and you look around and all the objects are there, you'll start seeing examples of things that transform all over the place. You might actually see a device that transforms and you may say, well, I think I could actually make that device better. And if that's the case, then you could file that away, and then it might give you other ideas. Or you might see two different transforming devices and you'd say, well, I could put these two together and make something different. On Mars, on the one hand, you want to have a rover that can move very slowly and precisely, so you can move over kind of flat terrain and go to a very specific rock, for example, and study that rock. But there's other times when you have to travel some rough terrain or go down a hill. So that was kind of the idea of saying, well, let's build a rover that can traverse like a normal rover when you want to be very precise. But then if you want to roll down a hill, you can actually kind of fold up into a ball and roll down the hill. And then when you get to where you want to go, you pop back open into the traditional rover shape. So that's an example of a situation where being able to transform, enables missions on Mars that you couldn't really do any other way.